Hello there.
Let's talk science.
Yeah, Mr. White. Yes, science.
We all know of those experiments online where they feel like magic, but are just in fact just physics. Well, today I'll be showing you a few examples and experiments to demonstrate a basic law of electromagnetic physics, Coulomb's law. In words, Coulomb's law states that the amount of force between two electrically charged particles at rest is directly proportional to the product of the magnitude of their charges and inversely proportional to the squared distance between them. Before we see this law in action, let's just decipher what that means. Two objects, charged and resting, will be more attractive to each other the closer they are. Simple. Now just to tell you that this is true, I have my past self here doing this experiment. You can see as he charges this balloon and brings them towards the papers, you can see that these paper pieces are only really sucked in when the balloon gets close. This is one of the more everyday examples. Here's a more advanced one. Ever wondered how the laser printers work? These bad boys also work using the principles of electrostatic charge. This laser thing supercharges parts of the roller with an opposite charge. This, as you can imagine, create a pattern of negative charges as the rollers continue to roll. It will attract the opposite signed toners from the orange developer roll and then get sucked onto the paper by a final transfer roller. Neat. Okay, do you understand the point of Coulomb's law now? Let me just add that the force between these 2 point charges is a vector. So, if they have different charges, they'll attract, or if they have the same signs, they'll repel. Because there are only really 2 charges, right?
This question can be phrased better, because just like mass or color, charge is just an inherent property of matter. You don't ask why mass exists, because it just does. The question we should beg is, why do people know that there are only 2 charges? Well, this started all with Benjamin Franklin's groundbreaking experiments in America in the 18th century. Franklin was curious about the mysterious phenomena of electrical attraction and repulsion. Through his work, he introduced the terms positive and negative charges. Across the Atlantic, in Europe, a French physicist named Charles Augustin de Coulomb was captivated by the same enigma. Coulomb delved into this mysterious realm of electric forces and formulated Coulomb's law. His mathematical expression described the forces between charged objects, providing a quantitative framework for understanding attraction and repulsion of the charges. Afterwards, in the early 20th century, scientists like Ernest Rutherford delved even deeper. Their experiments revealed the presence of positively charged particles within the atomic nucleus, which were named protons. This discovery, along with the electron, solidified the understanding of 2 fundamental charges within matter, positive and negative. The collective efforts of these scientists over time unveiled the secrets of electric forces in the dual nature of charges, forming the cornerstone of our knowledge of electricity, magnetism, and the structure of matter.